So thank you for a nice introduction. So it is my pleasure to be here and present our hybrid computing platform project and called JHPC Quantum. And first of all, I would say that and congratulations for a new installation of the quantum computer in Yonsei University. So I'm looking forward to collaborate with you to operate and how to use the quantum computer. So currently, I'm a division director of the Quantum HPC Hybrid Computing Platform Division in Riken Center for the Computational Science. So before presenting my project, I'd like to introduce myself and our centers. So our center has the mission to operate in national flagship machine of called Fugaku. And the Fugaku is the large-scale, many-core based and massive parallel machine. So, and I was working for the project to build this supercomputer from 10 years ago, and this machine is started in a public service from 3 years ago, and I'm moving to the project and conduct the project to combine this supercomputer with the quantum computer. So we named that project is JHPC Quantum, and the formal title is that very long research and development quantum and supercomputer hybrid computing platform for the exploration of the uncharted computing capabilities. So our project is started the November of 2023, and the 1 year and 4 months is already passed. And 5 years project, and the member of our project is Riken and the SoftBank. That is the famous mobile phone company in Japan, and also in University of Tokyo and Osaka universities. And the mission is that, of course, R&D of system software to combine the HPC and the quantum computer. Not just only the development of these software, that we are going to build the actual platform, using and installing the actual quantum computer from IBM and Quantinuum with our flagship machine, the Fugaku, and also University of Tokyo and Osaka University's supercomputer. So, of course, the scientific goal is that demonstrate the advantage of quantum HPC hybrid computing, a hybrid application, especially against the existing application, but only using the supercomputer. So, and not just the scientific goal. So, our project is supported by the funding agency, which is managed by the Ministry of the Industry and Trade. So that ministry requests us to making the quantum and HPC hybrid application as the services for next generation of the internet, so post 5G. So the platform we are going to build, and currently we are working on this, but so the unique point is that we are going to install the two kind of quantum computer. One is the ion trap from Quantinuum, and this machine is already installed in the Wako campus. And in May, the IBM machine will be installed in the Kobe in the same building of the Fukaku. So these machines will be connected in a high-speed network. And we also have a small scale, middle scale of the GPU machine. And then we are putting these systems together. We are going to make the quantum HPC hybrid computing platform. Of course, our partner, University of the Tokyo and Osaka University has supercomputer centers. So we have planned to connect our platform to their computers also, supercomputers also. So, and why the quantum HPC hybrid computing platform? So I think I don't have to explain in detail about this, but I'm coming from the HPC. From HPC point of view, the quantum computer is kind of the accelerator. So the offloading, some useful computation to the quantum computer from the supercomputer. So you can imagine the accelerators as accelerators GPU. So I think the quantum computer is very different from a GPU because current quantum computer needs the special the operation environment like a cryo environment. So in that case, we need the technologies to integrate in a system to system. So quantum computer is also system and the supercomputer system. So we need an integration system to system. So of course, a lot of demand from the quantum computer side. So currently, the number of qubit is the 100. So and even by the IBM. So it's not so much the computing demand for error mitigation or optimization, but in the meantime, the number of qubit is going up to the 1,000. In that case, I believe that we need the more computation for error mitigation and optimization. So supercomputer can help that. And of course, to design the quantum computer algorithms, I think in a large scale, the quantum simulation is very useful. So let me talk about the hybrid, what kind of application we're looking at. So as many people is pointed out, current quantum computer is a NISQ machine, and VQE or variational algorithm is the main application for NISQ machine. So even that, we are looking at two areas. As a first target, the application area. One is the quantum chemistry. So in this morning, at the beginning of this in a conference, Jay is already talking about our the collaborative project with IBM, the quantum-centric supercomputing. And in this project, we're looking at the quantum chemistry. So, and quantum simulation is the very the expected and the promising application area for the current quantum computer. So now the number of qubits is more than 100. So I think it is somewhat enough to simulate in a certain scale of quantum system. But current NISQ machine has many problems. One is the noise, and another is the very short time for the decoherence. So, as a result, so it is difficult to execute in real the application in a current quantum computer. So, and recently, is IBM and Jay there, and the declared the world and using the world of the quantum utilities how much useful for how to use the in the current quantum computer. So we are very supportive for this concept, and it is important to demonstrate how much useful the current the quantum computer. So IBM and Riken wrote these papers to demonstrate the effect, the quantum utilities. So, and in this application, we propose a sample-based quantum diagonalization algorithms. That algorithms is using but a lot of the execution by the quantum computer for sampling and collecting the data and diagonalization can be executed in the large-scale computation by the Fugaku. So in the previous papers, calculation, both calculation is done offline. That is the quantum computer science, the supercomputer side. But now is we are working on they're putting it together and online and do the iteration to define the solution. And the next area we're looking at is the quantum the machine learning. So I think recently many people is interested in kind of transfer learning, combining it to the deep learning process. And I think in the transfer learning with the classic by the GPU and quantum machine learning is a very interesting application area at this moment. Okay, so and for the system software, at the beginning of our project, we did kind of small the experiment connection between the supercomputer Fugaku and quantum computer, which is made by the Riken. So Riken is Riken Center for the Quantum Computing is made the superconductive qubit machine called A. So we are going to we did some experiment by connecting the Fugaku to the quantum computer A. So usually quantum computer, current quantum computer is used within a cloud. So users usually log into the cloud and get a certificate and making some quantum circuit and submit and get a result. So in a upper the flow, we did a kind of implementation for connection between the Fugaku and this A computer by the technique of remote pressure call. So this experiment is successful, but we found that the many problem. So I would say that this type of the programming by just using the RPC is not enough to be used for hybrid computing. So first problem is we need some coordination between the supercomputer and the quantum computer. So most of quantum computer is managed by in a cloud, and classical counterpart is the single node CPU. So in that case, the classical part is very, very cheap, and against a very expensive the quantum computer. But in case of the supercomputer, supercomputer is also the very expensive computing resources. So, and bad things is that if you think about an MPI, multi-node program, once this program is running, we cannot stop. And of course, the quantum computer is a very important the computing resources. So we need some scheduling and scheduling or the coordination to be used for these computing resources to be used more efficiently. So we need something. And another small problem is that programming environment. So the Qiskit is a very, very major the programming environment for the quantum computer, but it's based on a Python framework. So Python is a very, very, very good, very useful language, but in a context of the HPC, it's not so easy to use. So usually, the HPC application is written by an MPI, the C and C++, even in Fortran, very old language. And we need a we need a programming environment combined to the HPC program to the computer program. So we offer the two-level the programming model for the HPC and quantum application. Upper level is the workflow. So, and workflow is that controlling the multiple the independent program by the workflow tools. So you can see it can be the classical program. This can be in a quantum program. This flow can be controlled by the workflow tools. So, and in this case, the program, the hybrid application is composed by independent program of HPC and a quantum program. Then there is, so, but some application need to be more tightly integrated. So, and in that case, we provide a more efficient the interface by remote procedure call to execute the quantum circuit within the program. In that case, results can be managed by during the HPC application is running. So, of course, we are going to provide a Qiskit environment. So this is mainly for the development. But usually, HPC application, the supercomputer is managed by the job schedulers. So users usually submit the job by the QSub, the job scheduler command. And we are providing a workflow and also an HPC programming framework. Okay. So, and let me talk about our system design policies. So, first priorities is that support the quantum HPC hybrid program by making the quantum program and HPC application more efficiently. So system should be that enables the efficient use of the HPC and the quantum as well as the quantum computer. And next one is that we want to manage by our own the users. So and here. So and also we are going to provide a more HPC oriented programming environment based on C and C++, as well as the Qiskit environment. So and this is an overview of our the design. So and here the supercomputer, and this is just a cloud and a single server environment. And this is controlled by the workflow. And we are going to make another schedules by our own. And this schedule is the important element of in our system because two things. One is the authentication, and this is important for users management by our own. And another is the priority management from HPC. So this scheduler is control the priorities for each request from the supercomputer and the single node. And then this scheduler enables the execute high priorities request from the HPC. So, and we also support in a multiple the supercomputer. In that case, we need some kind of negotiation between the supercomputer to share in one the quantum computer. So we are now implementing in a kind of a coordination the middleware to coordinate the supercomputer in different sites. Okay, let me finish in presenting schedules. So this year is a very, very important and exciting year. So, and as I said in the beginning, the quantum computer is already installed. And from the February last month, that's quantum computer is available. And in May, IBM machine is installed in Kobe. And this year, we are going to start in a test operation. And from year of 2026, we are going to shift more in the operation, this system. And we are going to provide in this platform for the application users to demonstrate in effectiveness or the quantum utilities by their application. So, and we started in a test users program to invite external users who are interested in using our the quantum HPC hybrid computing platform. So if you are interested in our program, please contact me. And I think external collaboration, especially the Yonsei University, is very, very welcome in the future. Thank you very much.
Thank you very much, Professor Sato. And we have time for one urgent and short question. If I may take the opportunity, you said you used 6,400 nodes of Fugaku with the quantum computer. So there's some headroom, right? You have 150,000 nodes. So,
of course, but I think so most of users using in 1,000 nodes or something, and we have a large number of the nodes, but these computing resources will be shared by the many users.
Okay. So for scalability, if the quantum computer grows, it would not be a problem in the foreseeable future. Like if the quantum computer has twice the number of qubits, then the supercomputer will be able to accommodate.
I don't. I have no idea, but so you know, the next. So the Fugaku project is finished, and now in Fugaku is operated, and next project is started, and new machine will come in 2028 or 2029. So at that time, the computing capability will be in 10 times 10 times more.
Okay, it's
Thank
already
you.
scaling here. Thank you very much. Let's thank the speaker again. Thank you.